So this is lesson 1.7 in your algebra book, talking about data and spread. We're going to look at some words you've seen before: range, mean, median, mode. And we're going to just dive a little deeper with those things than you have done in the past and look at some special ways of using it. One specifically is mean absolute deviation. We'll jump into that. And we're going to look at sets of data and whether they fall under symmetric, skewed left, skewed right, or they're uniform. So first, let's run through these definitions and make sure we remember everything. So range is the distance from the highest to the lowest number in a set of numbers. So basically, you've got your smallest and your biggest, and how spread out are they? So you just subtract those two numbers to find the range. The mean is your average. So to find the average, you add them all up and you divide by however many there are. So it's the sum of the numbers divided by the number of items. So if there was 25 people in the class, you would add up all of their grades or whatever it is you're talking about, and then you would divide by 25 because there's 25 of them, and that'll give you the average, just like your test average. Add up all your tests and then divide by how many tests you've taken, and then that's your test average. Median is the middle number. Okay, and in middle school, we probably taught you to just look at the word, and you can tell it looks like the word middle a little bit. So it's the middle number in a set of data. So you're going to line them all up. They have to be in smallest to greatest, and then you pick the middle one. If there's an odd group, then there's always a middle number, because let's take the number 7, for instance. You're going to have 3 numbers on one side, 3 numbers on the other side, that's 6, and then one odd one in the middle. So anytime you have an odd number, there's an odd number in the middle, and that's your median. If there's an even group, you're going to have 2 middle numbers, and we average those together, which means add them up and divide by 2. Mode is the most common number, so whichever one shows up the most, mode is the most. You can tell that those also kind of look alike. And now we're going to start looking at these new words. Maybe you've used the word symmetrical before, but not specifically about data. So symmetric is when the values are on the left side and the right side are roughly mirror images. So this is symmetric because there's kind of that bubble. If you cross it down the middle, it actually would be symmetrical. Now, if you look at these two, I honestly get mixed up with these sometimes because you've got skewed right and skewed left. So what's going to happen is this little arch or this little bubble is going to lean one way or the other. The name of it actually is going to be opposite of the way it's leaning, and that's why I get mixed up personally. So skewed right is a bubble of data on the left side and a tail on the right side. So the bubble is going left, and they call this the tail when there's a little bit extra on that side. So there's the short tail, and you got the longer tail. So the longer tail is on the right, that's skewed right. And then when the longer tail is on the left, that's skewed left. And again, you got to memorize those. I still get them mixed up. And then uniform, the data has roughly the same height for all values. It doesn't matter where you go on this. It's uniform. It's the same. All right, so let's jump right in. If you flip it over, got example number 1. The data here describes various room sizes at Montague High School. We're going to use the data to answer each of the following. How many rooms have 700 square feet? How many have 750 square feet? So the first question here is just making sure we understand the graph. So each one of these circles represents a room, areas of classrooms. And this says that Central High School, Montague High School, whatever. So specifically, how many rooms have 700 feet? And the answer here is 1. How many have 750? Each one of these represents a room, and so that would be 5. So we're just making sure we understand what this is. So one room has 1,000, one has 900, 2 has 800, on and on and on. So what's the mean of the data? So mean, again, is the average. You're going to add up all the numbers and divide by how many you got. Really, the only way I could see you messing this up is if you just counted 1 600 and 1 650 and 1 700, and you just, anywhere there was a dot, you added them, or if you just added every number you saw. But other than that, it's really hard to mess this up. You're going to add up each one of these dots. So 600 plus 600 plus 650 plus 650 plus 650 plus 700, on and on and on and on. And then divide by how many dots you have. Now, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 rooms. And so we're going to add up all of the different areas and divide by 15, and that will get us our average. So if I was going to write this whole thing out, I'm actually going to come over here so there's some room. Instead of doing 600 plus 600 plus 600, repeated addition is like multiplication. So I could do 600 plus 600, but I could also do 600 times 2. I could put 3 650s or just say that it's times 3. Only one 700. 750s, we said that there are 5. 2 800s. 900, just one, and I'm running out of room here, but I will add it in here, 1,000. And then once I get this sum, once I add them all up and get an answer, I'm going to divide by 15. I wouldn't try and plug this all in your calculator at once. And if you were going to put all of this added up divided by 15 in your calculator, you would need parentheses around the top part, because otherwise it's going to divide first. It's going to follow the order of operations. So it would do 1,000 divided by 15 and then add everything, which is not what we want. We want them to add up everything on top. So in parentheses, divided by 15. But I would just go ahead and do the math first and then divide. If you add up all these numbers, you should get 11,100. And you're going to divide that by 15. And that comes out to 740 square feet. Now, let's say you got a number like 300, or you got a number like 1,500. You should know that doesn't make sense. An average is going to fall in the middle of your data. So 740 is right here in the middle of our data. That makes sense. All right, so adding up all the numbers, dividing by how many there are. What's the median? Median would be your middle number. So they need to be in order, first of all. So if you wanted to write this out, you'd have to write 600 and 600 and 650, 650, 650, 700, 750, 750, on and on and on. Instead of doing that, the easiest way to get to the middle is to just cross off one from each side. So you could just cross off, cross off, cross off, cross off until you get to the middle. But you could also think about this 15 is going to be split into 7, 7, and 1 in the middle. 7 and 7 is 14, and then since it's an odd number, I'm going to have 1 in the middle. So 7 on each side and 1 in the middle. So I could just count 7 in, and then the 8th one is my middle one. So 1, 2, 3, 4, 5, 6, 7, and the 8's going to be right here in the middle. Okay, so my median is going to be 750. If you had done the cross off, you would cross off on each side. And it really doesn't matter if you cross up from the top or the bottom, but we're going to cross off, and you're going to be left with 1 in the middle. So the median is 750. The mode is the one that you see the most of. So I have 5 rooms with 750. None of the other ones have more than 3. So my mode is 750. My range, smallest number is 600, largest is 1,000. So you want to know what's the range, how far does it stretch from the smallest to the largest? So you're just going to go ahead and subtract those, and you're going to get 400. And now we get up to this new one that we haven't done before. Mean absolute deviation will be abbreviated like this. So what the mean absolute deviation is it basically tells you how centralized your data is, or if your data skews way off in all different directions. So let's start with following a procedure, and then we'll talk about what it actually is. I think it's easier if you can see it first before we actually go too deep and start talking about it. So I'm going to give you a couple steps to copy down. Number one, you're going to find the mean, which we already did of this data. Okay, our mean was 740. Second step is you're going to subtract the mean, and this is the worst part. Subtract the mean from every piece of data. I'm going to say every data value. And that's tedious because there's 15 of them. So I'm going to have to subtract it 15 times. That's the worst part. Next, I'm going to take the absolute value, meaning if it's negative, make it positive. Absolute value. So no negative numbers here. And then I'm going to find the mean of those answers. So you find the mean, subtract that number from all of your pieces of data. If you have negatives because of the direction you subtracted, just turn them to positives, get the absolute value, so no negative numbers there, and then just find the mean of all of those. Here we go. So we already have the mean of 740. We're going to have 15 pieces of data here that we have to subtract that from. So we should get 15 new numbers. Basically, what you're going to be comparing is how far is each one of these pieces of data from the mean? Are they way far away, or are they really close? And then each individual one is going to give us a different number. And then we're going to find the average of those. So on average, how far off is every piece of data from the median? If these were all, from the mean. If they were all in the middle, then we would have a very, very small mean absolute deviation. And then if they were all spread out, you could have a bunch down here and a bunch down here, and they'll still average out in the middle, but that's going to create a much larger mean absolute deviation and tell you that the data goes way left and way right of our average. So it's basically telling you how much data is left and right and how far away it is. So I'm going to have two 600s. I'm going to go ahead and write these down. Each one of those is going to get subtracted by 740. And basically, you're just trying to find out these pieces of data that are 600, how far are they from the average? How far away are they? So when I subtract this, I'm going to get negative 140. Absolute value, though, is 140. We're really just measuring a distance. And so we're never going to express that as a negative number. How far are these pieces of data from the mean? So they're 140 away. I've got three 650s. And all of those, how far are they from our average? Now they're all going to be the same, so I'm going to do the math once. So those are 90 away from our average. So I have three 90s. And I have a 700, one 700, and it's 40 away. Five 750s. 1, 2, 3, 4, and 5. Now, you can get better at shorthanding this as you go. But for now, I want you to actually see all the numbers. And so each one of those is 10 away. 5 of those. Two 800s, which are 60 away. Running out of space here, but we'll come over here. 900 and 1,000. So that's 160 off, and this is 260 off. So that piece of data is the farthest from the average. All right, so I've created 15 new numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Doesn't hurt to take that extra couple seconds to double check. Make sure you have 15 pieces of data. If you don't, then you know you just made a silly mistake somewhere. So we've got it. And now we're going to find the average of all of those. So we're going to add them all up, and we're going to divide by 15. So I've got 140 two times. I've got 90 three times. I've got 40 once. I've got 10 5 times. I've got two 60s. I'm going to keep going right here, and I have one 160, and I have one 260. And I'm going to add all of those up, and I'm going to divide by 15. When you add them all up, you get 1180 divided by 15. And you're going to get 78.6 repeated. Okay, and that's your mean absolute deviation. And you might say, well, why did I have to go through all that? So again, what this number tells you is on average, every single piece of data is off from the average from 78.6. So that's kind of far. The closer you get to 0, that means the closer all the data is from the middle. It's more clustered. If it's more spread out, this number gets bigger and bigger and bigger. So you could have two sets of data with the same average, but one set of data, it's all clustered together, and one set of data is more spread out, but the average is the same. So the mean absolute deviation gives you an idea of how spread out that data is. All right, we're going to try one more. If you flip this over, let's run through this one real quick. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Looks like 19 pieces of data. Talking about goals here. So we're talking about soccer team scoring goals. So this means in 3 games they scored 0 goals. In 6 games they scored 1. In 6 games they scored 2. 3 games they scored 3. And then they had this one game where they scored 5. So what's the mean of the data? So we're going to have to add up all of this. I'm going to do it over here. So we have 0 3 times. We have 1 6 times. 2 6 times. 3 3 times. And a 5. And you're going to divide that by however many you have. Always doesn't help. It always helps here. If I add up these numbers, this is how many times I have each one, and this would be a 1. And if I add those up, I better get 19. So 6 and 6 is 12, plus 3 is 15, plus 3 is 18, plus this one game with 5 goals is 19. So I have 19 accounted for. Add them all up. That comes out to 32 divided by 19. Comes out to an average of 1.7. So they're averaging 1.7 goals, almost 2 goals. And that should make sense. 1.7 would be in here, and that's pretty much in the middle of the data. What's the median of the data? So remember, 19 goals. I like to take one less, 18, split that into 2 pieces. So 9 and 9. 9 and 9 would be 18, and you're going to have your 1 in the middle. So you have 9 pieces of data on the left, 9 on the right, and then that 1 in the middle. So if I count in 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, that means it's 10 is in here somewhere, and I should have 9 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 on this side, 9 on this side, and 1 in the middle makes 19. And so my median is 2. What's the mode? There's 2 modes here. 1 and 2 goals. Both show up 6 times. So you can have 2 modes. It's 1 and 2. There's a tie. What's the range? Going from the smallest to the biggest, from 0 to 5. That's 5. And now let's go ahead and do our mean absolute deviation. So first we got to find the mean. We know it's 1.7. Now we want to figure out how far off all of these are. So I'm going to show you just a shorter way now to do this, now that you've seen it. So first of all, we have this 0. How far is that off from 1.7? Well, it's 1.7 off. And now I'm just, instead of writing it 3 times all the way out, taking up all that space, I know that there is 3 of them. About 1 minus 1.7. Well, 1 minus 1.7 is only off by 0.7. And there are 6 of those. How about 2? How far off is 2 from 1.7? That's only off by 0.3. And there's 6 of those. Next piece of data is 3. How far off is 3? That's 1.3. How many are there? 3. So 3 1.3s. And then you have your 1, 5. And 5 would be 3.3 off. And there's just one of those. Always helps to add these up. Make sure you have the same number. So we should have 19. 6 and 6 is 12. 3 is 15, 18, 19. We're good. So this is what's going to get added up and divided by 19. So you could even add it up right here, going straight down using your calculator. You end up, when you add them all up, with 18.3 divided by 19. And when we round that, it's approximately, the little squiggly equal sign means approximately because we rounded it, 0.96 goals. So that's not the average. The average amount that they scored was 1.7. 0.96, though, tells you that they were on average, how close were they to this? They were about 1 goal away from that at all times. Okay, you're going to have your 1 over here, the 5. That was a whole lot more. But for the most part, only being 1 goal away from the average is not that far. So we'll spend lots of time with mean absolute deviation, but it's one more piece of data that describes kind of how this data is situated. So the mean tells you what's the average, what's the middle. But again, you could have a whole bunch of data here close to it, and that's going to look different than a whole bunch of data that's spread out, but still has the same average. Because as long as you have the same on the left and the right, the average will fall in the middle. But it could be super spread out on both sides with this average, or all of the data could be clustered close together with this data. And that's what the mean absolute deviation tells you. A small number here means it's clustered, and a big number here means on average, the data is actually pretty far from that middle, that average right there.